let's see. I think we've got 4 panelists, so as moderator, I'm going to be standing for the next hour.
The wire tray.
Yeah, good? Yep. All right, great. So we're here to talk about the moon, and I'm going to tell the panelists first that my first question is going to be, why the moon? But first I want to start with a bit of a history lesson. You know, as someone who's been here through a lot of the history, it's surprising to me that 60 years almost, 56 years after we landed on the moon, we have not been back. I would not have thought that when I first came to this town more than half of that time ago. But so how has that unfolded? Why is it that we have not been back? The reason we went to the moon in the beginning was obviously geopolitics and a geopolitical competition between the US and the Soviet Union. When we won that race, the great space race of the 60s, which we had been losing consistently through the decade, when we landed on the moon with Neil Armstrong and Buzz Aldrin, that was a Earth, awakening for everybody, not just those in the United States or in the Soviet Union, but worldwide. It was a monumental achievement. The second time we landed, people paid a little bit less attention. And by the 6th time we landed, nobody was paying attention at all. The US space program moved on from there to do the space shuttle and eventually the space station. But from a NASA perspective, they were always focused on trying to get back to the moon as the next, and then going on to Mars as sort of the next logical steps for human spaceflight, with the shuttle and the space station as interim steps. So there were 3 different attempts in that, let's say 55, 56 years, to get back to the moon from a NASA perspective, and every one of them failed so far. The first one was the Space Exploration Initiative, announced by President George H.W. Bush, July 20th of 1989. That was the 20th anniversary of Apollo 11, and that great space exploration initiative was, we're going to go back to the moon again and then on to Mars. The space station was in progress. The shuttle was up and flying. And it quickly ran into a roadblock of a $1 trillion budget estimate that the NASA folks came up with themselves. So NASA came up with this budget estimate. It was dead on arrival. And they, through the 4-year term of Bush 41, they churned about how to do it, new cost estimates, different ways of getting back there, ultimately to no avail. When the Clinton administration came in after that in 1993, they said no talk about the moon, right? It was just, we're going to build the space station. Well, they actually early in the administration decided to build the space station, or save the space station, if you will, as the bumper sticker read at the time, by bringing in Russia, the former Soviet Union, bringing them in. Congress almost voted to kill the space station. It survived by 1 vote until they brought Russia in, and then it was a foreign policy tool again, and it survived every year since then with quite bipartisan support. But that became a stuck in Leo, if you will, kind of mantra, with the space station being the destination for the space shuttle. That all changed on February 1st of 2003 when the Space Shuttle Columbia accident happened, right? There was earlier a Challenger accident, but that didn't, that preceded the Space Exploration Initiative. But when the Columbia accident happened, the question of what are we doing in space with human spaceflight became very real. Why are we just going in circles, as detractors would say? And there was a debate within the government. I was fortunate enough to be part of that. But the result of that was what became known as the Vision for Space Exploration, which George W. Bush, Bush 43, announced in January of 2004 about finishing the space station by 2010, retiring the space shuttle, and then returning humans to the moon by 2015. As far as I know, that didn't happen. As late as 2020 was the window, and that didn't happen. That ran into another attempt at NASA. NASA Administrator Mike Griffin came up with what was known as the Constellation program to go back to the moon using shuttle-derived parts, building what is now known as Orion, and the budget estimate for that tripled over the course of the next several years. When the Obama administration came in, they set up a commission headed by a very famous executive from Lockheed Martin named Norm Augustine. The Augustine Committee looked at everything and said, they were tasked with, is it broken? If it's broken, how do we fix it? If you can't fix it, what do we do next? And they came up with basically saying, it is broken, don't go down that path. Go look to do something that doesn't involve landing on a surface, meaning what they ended up choosing to do was go to an asteroid because they thought that wouldn't, that would be cheaper. That effort kind of limped along for the next 5-6 years until the first Trump administration came in, and they immediately said, we're going back to the moon. The moon's where it's at, and they geared up everything back to going to the moon. Administrator Bridenstine came in about a year into the administration and officially coined the program Artemis, the twin sister of Apollo. It all sort of made sense, and those of us that were in the moon camp were very excited to be going back to the moon. That was almost 9 years ago, 8 years ago, I guess, and we are still talking about where are we going. Now we are talking about a second Trump administration, and we all thought, great, with the Biden administration came in and said, yes, we're going to continue to go to the moon. That was the first time an administration changed parties and kept the same goal for human spaceflight in many, many years. And yet, we still didn't quite make it there. A lot of, water over the dam and under the bridge that we can talk about and decisions that were made. But now, in the last 6 months, what we've seen is this conversation about moon versus Mars again, and where are we really going? And without an administrator right now, the question is, do we really know what we're doing? Do we really know where we're going? Or are we going to continue to muddle through for the next few years? So, with that basic history lesson of the moon, for my part, I've always been a moon first person or a moon again person. I think there's a very important number of reasons to go back to the moon. But I want to address the panel with the first question, which I already gave you, which is why the moon? Why should we go back to the moon from a human spaceflight perspective and other things too? So I'm going to kick it off with you, Brad, for a philosophy discussion.
All right. Well, I think the first reason we need to go back to the moon is because your story needs a happy ending. Whew. History isn't always fun. So I'll say, just to take issue with one thing you started with, is where should we go? I'll point out we went to the moon, and our mission capstone has been there for almost 3 years. So we have been operating in the near rectilinear halo orbit as a pathfinder for Artemis, and Artemis 1 went uncrewed, and so I think we've made some progress. But to get to your actual question, I kind of go back to the why for me, and so why we started Advanced Space, why we started a company, why we did this. It was to enable the sustainable exploration, development, and settlement of space. There's no scenario that I can envision where we are living and working in space and somehow we just skipped the moon. You might win a foot race like we did in the 60s to Mars, but for us to sustainably be living and working in space, the moon is part of that ecosystem or that economy. And so for us, as a company, our purpose is to get to that future, and so we're building and have been building even when the mission of NASA was to go catch an asteroid. We were building the technologies for position navigation and timing and operations at the moon that fortunately when Artemis was announced, we were ready to go do that, and we did that rapidly. We have several more missions that we're working on to go back to the moon. But really, I think it's to me, philosophical. It is the next step. I think I have a sort of a vision chart that I show in our company. You may be familiar, Elon has a picture of terraform Mars as his sort of like, inspiration. Well, our equivalent idea is a moon picture where you can see that there's like a lunar city there. It's lights at night, right? And so I think, to me, sort of philosophically, why is because every human who's ever existed, and all of us today, have, whether we know it or not, have a relationship with the moon. You've seen it, it impacts our tides. It's part of everyone's life since the history of humans, right? And so the idea of there being visible activity on the moon and people living and working there, I think resonates and sits with people in a way that space stations or Mars or anything else is almost like science fiction, and this is like the reality. People can relate to it, whether you're in a city with light pollution or you're in rural and you can see the Milky Way. The moon is a common thing I think everybody can relate to. So that, to me, is the why moon, because we're already there, and I think it is the stepping stone to that long-term future.
I also expected to hear the words national security from you, but I didn't.
Well, I think it's a priority for our nation to be operating in all orbital regimes, and I think maybe a upcoming question, but I think instead of a foot race like it was in the 60s, what we're going to see now, and we are seeing this, it is a global effort. We're not the only players in town, as Clay kind of set up for us, is that the norms of operations and sort of the rules that the future of the moon and other deep space activities will be guided by who is there and who is establishing them. So I think for our nation, it is important from a civil, commercial, and national security perspective. We have to have that leadership in establishing those norms. Otherwise, they will be established for us, and most likely they will be established for us by countries that do not share the values and the priorities that we do here.
Thank you. Thank you. Indra?
Yeah, thanks, Brett. Man, doing panels is tough, but when you have to follow Brad, Clay, Brett, and then Brad again, it's a really hard act to follow. I mean, they're so eloquent. Everything they talk to is true to heart and tons of experience. So I agree with everything that Brad said entirely on the philosophical and on the strategy and the strategic. What I can add maybe is on the practical side. And at Interlune, one of my day-to-day reasons for going to the moon and for not even having a chance for a nanosecond to think about something other than the moon is my co-founder. So one of our co-founders at Interlune is Harrison Schmitt, also known as Jack Schmitt, also the last man to walk on the moon.
And Senator Schmitt.
And Senator Schmitt from New Mexico. Jack will never let us forget Brett's point that we went to the moon over 50 years ago and we have not been back. And he's written a book on why we should go back. He's talked at conferences up the yin yang of why we need to go back. So that's the day-to-day practical reminder that I've got to go back there. The other practical part, and we've been talking with our industrial partners, our sector partners, working with Advanced Space and Brad's and Yasmin's team, is when you're talking to an engineering team and you're designing equipment and infrastructure, and like Brett said, we're returning to the moon, not to go there, footprints, plant a flag, and go back. We're going to stay and to do operations and to be there. When you talk to engineers about that, there's a development path and there's a test bed that's needed. And if you go to these brilliant practical engineers and you say, yeah, forget this planetoid, this body that we see every day, that takes us a couple of days to get to, that we've been there before. There are people going there, almost every quarter now. Let's aim for this over here. That takes, you get a transfer window every couple of years. And let's use that as the test bed as we're testing all this out so skipping over it. And if you talk to engineers about it, they're like, well, yeah, we're starting with the moon. We're not going to stop at the moon, but we're going to start at the moon because it makes sense. So when you hear the discussion at the policy level, you hear the discussion in the hallways, it's good to take that all in. it's also good to calibrate that with when you talk to companies and brilliant people that are actually designing the equipment and designing the operations, how to actually function on the moon. Almost all of those companies are talking about a step process, and they're all talking about including the moon and then pushing outward. So there's the chat, and then there's what's happening, and so I'm just happy to share that.
Great point. Switching over to this side of the table, Marchel.
Hey everybody. My name is Marchel Holle. I work for a company called ispace US. We are a global lunar exploration firm, and we have a vision that we call Moon Valley 2040, which is to see thousands of people living and working on the surface of the moon. And I think, I really echo a lot of these comments that, why go to the moon is very much intertwined with these bigger ideas about why go to space at all. And I think that is a bigger philosophical question that has a lot of really ultimately intangible reasons behind it. But I think if you were to poll a lot of Americans and you said, what were the most important events of the 20th century, I think moon landing would be very high on that list. So even if it's difficult to articulate it, there is something there. There is something very important there. But I see, this takes a global effort. We have iSpace. We're based in 3 big locations. We have a large presence in the United States, Japan, and Luxembourg. We have over 30 nationalities work at the company, and I think ultimately this international cooperation and norms development is really at a tactical core. We see a lot of international competition occurring right now, great power competition, and there was a senior space policy expert remarked to me recently that, to the extent that the 21st century or 22nd century might become like the Chinese century, historically he predicts that Chinese having a sustained presence on the moon will be seen as the beginning of that century. When you go to these international conferences, people see that China is making huge strides to sustainably work and operate on the lunar surface. They have a program called ILRS, or International Lunar Research Service. They are making tremendous amount of international partnerships all across the globe, and they're going to use that to shape the future of space exploration. And I think, as a company, again with a large U.S. presence, we seek to really preserve a lot of the norms that really see as very tremendously valuable. And I think that means, learning to land on the moon. I think you guys are really, Firefly being a great pioneer, landing on the moon as well. But I think landing on the moon is very hard, and so we can't really skip it to go straight to Mars. It's very important that we, buy down as much technical risk as we can to learn to operate in that environment.
Yeah, I'll wrap it up on this question. My name is Ray Allensworth. I'm the spacecraft program director at Firefly Aerospace. So I feel like I've been to the moon recently with our lunar lander. At least part of my soul's up there, it feels like. So when you talk about why do we go to the moon, I think Blue Ghost Mission 1 in partnership with NASA's Commercial Lunar Payload Services is a really good demonstration of why it's important. It's accessible, but also we were able to take 10 different science payloads on board. And these are payloads that were through other NASA centers. There were international companies on board. There were research institutes. There were nonprofits. So we were able to take all these different payloads from all these different entities on a single vehicle and give them access to space. And that's something that Firefly is really passionate about, is making space for everyone, so that you don't have to kind of form your own mission. You can jump on board this spacecraft and we can all go together. And the moon is extremely accessible. And so it's a matter of days to get there rather than several months or years, for example, to get there. And we're able to go there and demonstrate technology, push technology further. But we also learn a lot about the Earth while we go. Many payloads on Blue Ghost Mission 1, they actually weren't studying the moon. They were landing on the moon and then looking back at Earth and studying the Earth's atmosphere and the magnetosphere and the space weather. So there's a lot of reasons to go. I'm definitely pro-moon, but I'm definitely biased in that as well.
I should have led with congratulations for successfully landing on the moon upright and operating for 16 days. Absolutely impressive, amazing to watch. And the imagery that came back from that was just fantastic, particularly that, that shadow at the end, right? So congratulations to that. I know how much blood, sweat, and tears you've poured into it over the years. You just have to do it a couple more times, right? Yeah. You've got 2 more awards, which is a good segue to the next question, which is, what is the role of government in all this, and in particular NASA? We have 4 private companies here. Unfortunately, NASA's Joel Kearns, head of the CLIPS program, was not able to join us. He fell ill, and thank you, Marchel and Brad, for stepping in for our panelists that weren't able to be here. But, NASA has done some things in the last 15 years, COTS CRS, a commercial crew. They've done some cooperation with commercial or done government programs in a commercial way that has really kicked off companies like SpaceX and this whole commercial revolution in space. And, now we're moving on to the moon. Is that really a commercial activity, or is that a government activity? Is that a combination of the two? So I'd really love to hear all of your comments about, what is the role of government, in particular NASA here. So we'll start back with you, Ray.
Yeah, I think it's a really interesting question. What's the role of government when we're going back to the moon? I think we're starting to see a shift to where the government agencies are now becoming a customer on a mission rather than owning the mission end to end. And there's a lot of efficiencies that can really be gained by that. Instead of sending an individual mission for every single science mission you have, every single demonstration you want to do, you can gather all of these different technologies and put them on one mission. And there's instead of doing a decade-long mission for $1 billion, you can do one mission that takes, less than 4 years and $100 million and get a significant amount of data across multiple, different payloads and objectives. So I think we're starting to see a shift where, NASA is focusing on tech demos, science, furthering, getting to the goal, Moon to Mars, a precursor to Artemis, having humans on the moon, taking all of these individual pieces and placing them with commercial customers who have this suite of payload space on whether it be a lander or an orbiter around the moon, and they're able to really partner with the commercial industry to make that happen really efficiently.
Sure.
Yeah, I definitely agree. It's really encouraging to see this shift in mentality to this services model, this lunar services model. And I think we see this new model helps, this focus on commercial allows the government to do more with less. When you have, you're able to take private capital and along with international cooperation and really get more than the sum of your parts. That being said, though, I think we envision a commercial lunar market that's thriving. I think it's currently still emerging. It's still in this embryonic stage. And I think, from my perspective, I see the role of government is to try to nurture that, is to try to close the value chain as much as possible. At ispace, we really believe in that water ice will unlock this lunar resources value chain. But there are several steps in the prospecting for the extraction of and the processing of this water ice in order to get it to a final customer. So I think the role of government here is to help develop that technology that private capital can then use to turn into commercial opportunities.
Yeah, please.
Something you said kind of triggered something in my brain. I think something that the government, I think, is doing really, really well, and you see it with things like the Artemis Accords. It's working kind of with other international partners who are also looking to send things to space. And so, we've actually partnered with several different Artemis Accords members, and they are now commercial customers on future missions that are going to the moon. So we're able to leverage this kind of arm of diplomacy through NASA and the Artemis Accords to fill, and help, make the commercial market, come to fruition.
Great. Indra, a different view on commercial.
Yeah, those are all fabulous comments. I mean, I agree with everything that was said, and I think the role of government in a new sector is to help get the sector off the ground. And for a lunar economy and for lunar companies, capital is king. We need money. Both from the private sector, so private capital, also government capital. And we're gonna get there further together. So it's a collaborative effort to get the government programs there, to get the commercial industry there, to get science, and to continue meaningful science. I think we're gonna achieve more together. But I think right now at this stage, one big role for government is providing the right signals, providing the right programs, providing the right support and communications that builds the confidence for private capital to come and to play a role, and also for public capital in terms of deciding between program priorities, of putting money to back companies going to the moon and programs going to the moon. And it's definitely a global effort. I completely agree with the comments before. It's going to take all of us, and it's going to take all of us working together to get there. But for me, I think that's the big thing that NASA can do right now, is just provide the confidence, support, funding, and that check in the box for capital.
Thanks. Yeah, great comments so far. I'd say, reflecting on the town that we're in and the building we're in, I think, part of the question of the role of government and with respect to the moon is, I think it's important to be clear that it is the law in the United States of America that these are the programs that are set to be executed by our nation, primarily NASA, but also other stakeholders in the government. And so it is less a what if, why not, but it is literally written down. I assume they still print bills in paper that is the job that they're set out to do. Now, how they're executing it is kind of the question, but barring a law that changes that direction, that's what the government's job is to go do. And our next speaker here will talk a little bit about that process after this panel, but I think that's an important thing, right? So the law of the United States is to go do this. So then the question is sort of, how do we go about doing it? And I think, the question is sort of like, what's the role of government? I would flip it around. In my mind, we're here as industry to help the government do that part of their job. And the goal that we look at is to say, how can we use the economies of scale, the benefits that we can uniquely bring, the supply chain differences. The world is a lot different than it was, as Clay mentioned, 5 or 10 years ago. Supply chains are different. There's a lot of things that have changed. And so our opportunity, as I see it from industry perspective, is to help the government to execute their mission. And the goal is to try to do that in a way that is hopefully quicker and cheaper for the government's mission, but then also creates residual capabilities and benefits that we can then, for non-NASA government customers, for international customers, for commercial customers, we can bring a lot of that same learning, a lot of those same capabilities to create entirely new markets and to do things, as we were talking about earlier with CLPS, that you couldn't justify a lander mission for maybe a single payload. But if there are 8 other payloads signed up, now you can, right? So we see that right now, and a lot of that aggregation is all inside of NASA or inside the US government. But what we really, I think, should be thinking about is, how does industry help the government to do the job that they're signed up to do efficiently, right? When we talk about the government, right, they're spending our tax dollars, it's our money, so we'd like to do that more efficiently. We'd like to do it quicker, because implied in Brett's intro is that if things take too long, they get killed, right? So let's try to figure out how to do it cheaper and quicker, and then figure out how to create new economies of scale and new opportunities so that new things can be done in space in general, at the moon specifically, that could not be done except for the fact that we're doing this great, sort of one team effort across industry and government to get to the moon and to do all the other important things in space.
Great. Let's talk specifics. We know that in terms of commercial services, that we have lunar landers that are now providing that service to NASA to land on the moon, to take science instruments, take commercial payloads, et cetera. What are the other services that commercial can provide that makes the most sense, right? My own view personally is not everything that NASA does in going back to the moon should be done commercially. There is a role for NASA other than providing funding for it. And so we have to make choices about what should be done commercially and what should be done in a traditional government way. So I'd love to hear your thoughts on that, and I'll let any one of you start. Okay, Ray.
Thanks for picking on me here. So, what should the government do? What should commercial do? I do think that we're kind of getting into a phase, where the line of that is very easily blurred. I think that commercial companies are really demonstrating that they have a lot of capability and they can do things that traditionally the government did. I speak primarily from a commercial standpoint. There's some things that I think we're really well suited to do, like gathering imagery or communication satellite activities out there. If you look at a satellite like NRO, for example, or LRO, sorry, this is a spacecraft that's been up there. It costs hundreds of millions of dollars. But on all of our future orbiting spacecraft that will be flying to the moon, we are also flying very high resolution cameras that also can look at the visible spectrum. They can help identify resources on the moon, different type of minerals, stuff like that. So instead of NASA dedicating a full mission or a full program to it, they can actually just come to us and say, can I buy this data set? I'm really interested in low lunar orbit data over the South Pole. Can I buy that from you? And so, instead of doing a solo project for it, they can lean on commercial industries that are already sending payloads there, primarily for other reasons, but have all these other, things, accessories on board that can provide really valuable data back to NASA.
So we've got landers, we got remote sensing, we've got communications. Those are great.
Right, and just to echo that, so ispace, we have a series of missions that have flown or are in development. So our first mission launched a few years ago. Mission 1 and Mission 2, very creatively named. You'll never guess what the third one's called. But these are R&D missions. But our third mission is, which we're working with our partner with Draper Laboratory, is aimed at the far side of the moon. And currently there is no U.S. relay system around the moon right now. So we're going to actually carry our own. We made the decision to develop our own satellites that we're going to carry with our lander and eject them into low lunar orbit to provide that relay service. And I think that's something that NASA is really looking to commercial, both around the moon but also around Earth, to kind of offload that more directed government spend. But I think at the end of the day, I think ultimately, there's this pipeline of funding. I think still at the beginning of the spigot, it is government that's really ultimately going to be putting that in and driving that demand signal. And again, I think having government develop technologies or buy resources that commercial companies can deliver, I think is going to be the real core of it.
Thanks. Indra.
Yeah, I think just following along that theme, it's exactly right. I mean, the way we kind of view it at Interlune is, and going back to the overall kind of theme of this panel is, the lunar economy. When you have an economy, I think of goods and services. I think of, provision of those items to many customers. And I think, for me, the key phrase is reoccurring. If you're going up and you're doing an activity and you're going to just be providing that service, providing goods, doing that over and over and over, and hopefully your market and your consumer base expands, I don't see that as the best use of NASA. NASA's brilliance, NASA's mandate, their vision and mission is do the hard stuff, right? Get there, do it, work with industry, meet the challenge. Once it gets into, you can call it the more boring, you can call it the more, it's the day-to-day. That's where I think, industry has a more enduring and a more valuable role, is taking over that function, taking over that capacity, and then providing it and in a continuing way, so that NASA's funds and NASA's expertise and energies can be focused on the next hard thing. And if you look at the way, we've expanded economic activity here on this planet, how we've explored, our own history in terms of the exploration of the West. That's the way we've kind of worked in terms of government and the citizens working together, pushing forward, setting up an outpost, government going on, doing the next thing, the outpost kind of building and growing gradually and providing things. So that's kind of my high level.
Great.
That's it.
I think great. comments already. I think, some things we haven't talked about. I believe the programs that are to do rovers and spacesuits and human landers are all using commercial procurements, just like we are for payloads, just like we are for ISS crew and ISS cargo. So I think there is a model that is being employed to get at the benefits of where commercial economies of scale can come from. And what that means is that there's things that can come out of these programs that if it was just a government-controlled program could not happen, right? Partnerships, co-investment, all these are things that as a purely government activity are really hard to work out. When it becomes a commercial industrial activity, there's a lot more creativity. There's also, I think, part of the piece here that we haven't explicitly said is that these approaches also bring competition, right? So it is not a single point design that some large committee of people decided and then we hope over the next several years it gets built correctly and executed, right? It is multiple different design approaches, multiple philosophies. We can try things. One of the things the space industry never really had was an equivalent to what we had in aviation of sort of the barnstorming era, right? Like there were hundreds of different aircraft designs. Many or most didn't work great, and we found that out because we flew them and they crashed, right? Space programs historically were very monolithic, single point solution, and if it turned out that it was the wrong single point, too bad, you kind of had to live with it and make it work. So I think what we see in this more commercial thing is that there will be multiple different solutions or approaches, and not just technical approaches, but also business model approaches. People may find different ways to bring down the cost or to add value to other stakeholders. And so I think what we'll see is a much more robust resulting solution space. So we'll find out that there are certain designs that are probably stupid, that we'll find out because they won't work, as opposed to spending billions of dollars and many, many years trying to fix a bad initial design. It'll fail and someone else will come and take that service or that reoccurring activity away. So I think that's where this is sort of a whole different opportunity space. It's really hard to do this, right? But the opportunity space here is now new ideas can come out, new technologies can get tried. There's not just one way to go to the moon, whether you're cargo or crew, right? There's multiple different things. I think that is part of the key. And then backing up again to the government's, the one right now that has that mandate and has that job to go do it. Now the government has options, right? They can say, oh, we like this, it worked, let's do more of that, or we don't like this, it didn't work, let's stop doing that, right? That's an optionality that government programs traditionally don't have because they set out their budget, their plans, and then they basically have to go execute to whatever those plans are. Well, now they have optionality just like, in a commercial market we all do. So I think that's an important piece that gets to the staying power, I think, of the architectures that we're seeing being built.
All right, I appreciate that. I couldn't help but think about the space shuttle in your argument there, the 30.
I said no names of programs. Please let the record reflect.
But I've gotten a lot of criticism over the years for typing the words "retire the space shuttle," but after 30 years and 2 accidents, it became more expensive and less safe, the time comes where you have to have innovation and multiple approaches. So I want to open it up to questions from the audience. We have about 8 minutes left. So who's got a good question out there? Right here. Stand up, say your name, and speak loudly. Okay. Okay. You want me to repeat the question? The question really is what research is being done in sort of new technologies as opposed to just applying older technologies towards lunar research. Is that correct?
Okay.
Ray?
I think it's a really interesting question. I think on Blue Ghost Mission 1, we kind of pulled the thread on what should we reuse and what should we kind of repeat a lot. If you look at our footpads, for example, those were very much of the Apollo age design. So we took that, but we made it out of composites. And a lot of our primary structures were made out of printed titanium. And so those are kind of newer technologies that didn't really happen in the 60s, at the scale that we're using them now. In terms of research, we partner a lot with research institutes. Southwest Institute, for example, we worked with them on multiple areas on the spacecraft. In our tanks, for example, there's really highly specialized propellant management devices in there. That is not a specialty that we have, so we partner with a research institute, so they help us design that. And then our specialty is really, manufacturing, integration, and test. So there's kind of a lot of different facets, at the individual component or at the kind of subsystem level, where you'll look to places like SWIRI, for example, to partner with, or even NASA. I think that's one nice thing. Even though it was a commercial service through the CLIPS program, NASA has a wealth of knowledge where you're able to reach out to different groups within NASA and say, hey, do you have a thermal expert, or do you have a comms expert? Can I have 20 hours of their time just to ask them questions, for example? So there's a lot of different avenues that we use.
Great.
From the lander perspective, one area which we're trying to understand a lot more is the concept of plume surface interaction, or plume impingement. So as the lander touches down, it lofts this, it sprays this regolith, and we don't really have great understanding of the dynamics of this or how far this goes. So for example, under the terms of the Outer Space Treaty, when we land, we have to declare a concept of a safety zone. But because we don't really understand how the engine plume interacts with the surface, it's hard for us to even understand how big should the safety zone be from the standpoint of international law. So there are a lot of really cool instruments that are flying, including I think it's called Scalps. Scalps, yeah. I think, did you have Scalps?
We did have Scalps, yeah.
Blue Origin is flying Scalps as well. That's trying to really understand this really, this very dynamic simulation as the engine exhaust hits the surface.
Great. Let's take another question. Let's see. Yes, right behind. Yeah. Yes. Okay, so the future of commercial LEO destinations to replace the space station, which is a NASA program activity for development. So anybody want to take that, and does it relate to the moon in a way? As we commercialize LEO, then we can work with NASA more on.
Given our location, I think we're allowed to answer a question that wasn't asked, right? Like that's what they do up here all the time. So I'll say I don't know too much about the specific deorbit activities. I think there's a clear pathway though from how what we have learned in low Earth orbit will extend to the moon. I think having commercial operations in low Earth orbit is obviously important and interesting. But I think the pivot I'll take is I think it's important to realize, yes, there's things we're going to learn like life support stuff that in low Earth orbit and at the moon or in lunar orbit are similar. But the pivot I'll take is I think there's also a lot of things that we don't appreciate fully that are not the same. So operating in low Earth orbit where you can get home in a few hours if you have a bad day, where you can have like real-time comms with mission control all the time, where your maneuver, everything's very predictable. It's on sort of like a daily schedule. Versus what we're going to have to figure out when we're operating consistently at the moon and then ultimately certainly at Mars. I think there is a lot still there, and it gets a little bit to the research question too. There is novelty in sort of operations and how we plan and execute missions that is not necessarily cool 3D printed titanium, but really like when are we going to do maneuvers? How do we do rendezvous and proximity operations in 3-body orbits? No one's ever done that before, but it's critical to every single architecture we have for getting back to the moon. So there's a lot of this like ConOps technology, how is autonomy going to play into that, or even like AI? There's a lot of, I think, questions that are not necessarily like bending metal or blasting regolith that we have to figure out, that is going to be, the reason I bring it up is because I caution, a lot of times we will think, well, we've been flying ISS for all this time. Obviously, we know how to do human space flight at a space station. But there's a lot of assumptions, even just on like what is the rendezvous safety protocols for low Earth orbit, that are based on being in low Earth orbit. So if you were going to go rendezvous at the moon or at Mars or somewhere else, some of that will not be applicable anymore. And I think there's a risk opportunity here again of, we know how to do ISS, so why do we have to think about this again to make sure we actually, the reality is most of the people that developed ISS are not there anymore. So you can't just go ask them, why did you do it that way? We have to really be thoughtful and make sure we're building those systems in the future that are using the right technologies and still maintaining that safety. So if you indulge my slight pivot, I think it's certainly important, but it's also important that we realize that LEO and Lunar are not the same, and we have to be thoughtful of how they're different.
Great, Brad. Thanks. We're going to wrap up now. I'm going to give each of you an opportunity to take about 30 seconds for any final thoughts. Brad, since you spoke already, I will start down at this end with Ray.
Final thoughts. Okay. I think just coming from the perspective of Firefly, where our main goal is to make space for everyone, and that includes partnership with NASA as well as other international companies and commercial companies. I would just I think it's really important to know that there's a really strong partnership here that has to happen, in my opinion, between government and commercial companies. And I think kind of to a point you made earlier is that we're at the very beginning of seeing that relationship really blossom, and that there's a really, really strong relationship between government and commercial customers, and that commercial industry for a sustained presence on places like the moon. I think we're at the very beginning of that, and I think over the next 5 years, you're going to see kind of this next step function of growth, which is really exciting.
Thanks, Ray. I think from our, my perspective is, we all want to see this thriving lunar economy, and I think to see that happen, we cannot go it alone from a commercial side, from an international side. This is going to take the entire world coming together to really make this a reality, and I think there's a lot of great opportunity in that.
I'm going to do this completely backwards because I realized at the very start of the panel I didn't even introduce myself or the company that I work for. So, and I can't see around.
Done that for everybody.
Yeah.
I'm sorry.
And I can't see around the podium entirely. But my name's Indra Hornsby. I'm COO for a company called Interlune. And Interlune is a customer and a user of my co-panelists here. We are a company that is focused on harvesting natural resources, and specifically harvesting natural resources from space. So we're looking at many minerals and many materials. Our first use case is helium-3, which is found on the moon and can benefit us here on this planet greatly in terms of innovation in the quantum computing sector. In the energy sector for fusion, it's critical to national security and has advancements in medical technology as well. So it's a supply chain issue, it's a critical resource issue, and we're focused on addressing it. But my departing comment, though, is that, for me, and I think Clay said this right at the start, I've been waiting for this moment for most of my career, and that's to build a company for the future, for everyone else, but it's to build a company that takes advantage and uses all the infrastructure that we've been working on today and that we've gotten very brilliant at in terms of the launch vehicles, the rovers, the robotics, the satellites. So just be talking about an enduring company and several companies that are going to keep going, providing this as a regular, reoccurring service is what I came to the industry decades ago, I hate to say it, to do and to be. So you all are well-timed. I'm really envious because I think your future, this is a transformational time, as everyone has said. You're sitting pretty. You're at the most exciting time, and I just encourage you to take full advantage of it. Experience everything you can experience across the sector, get your knowledge, and just go for it. You're going to have an amazing career, so I wish I was over there, actually. No offense to the panelists, but...
Thanks, Indra. All right, Brad.
What a master stroke, Indra, to do the intro at the end. And I never thought of that, but now everyone remembers that, and they don't remember anything else. So my departing thoughts would be, I 100% agree. This is an awesome time. I think we should be cautiously optimistic. I think there is tremendous potential, which I am incredibly excited and motivated by, but it is not going to be easy, and it's not going to be pretty, and it is absolutely not going to look like we think it's going to look if we sit here and tell you what we think. There's going to be business issues, technical issues, policy. There's going to be so much that we have to overcome. So I think, to me, part of how we get to exciting, fun future that we're all, totally in agreement is going to happen. We just never will agree on when it's going to happen, because it depends on how stubborn and relentless we can be as an industry, and that's everybody in this room. But we need to be stubborn and relentless at getting the things done that need to get done and overcoming the challenges. And it will not, like, our mission to the moon that we're still operating was not pretty. We had problems, things broke, we had failures we had to overcome. And that's the way this stuff is, right? There's sort of the saying, space is hard. Well, my caveat on that is, if space is hard, because I have not yet agreed that it is, but if space is hard, the moon is harder. So if we're talking about going to the moon and you think space is hard here, it's even harder out there. So I think as we think about that, it's sort of a relentless activity. The future is awesome, and it's going to be driven by all the people in this room, even the ones sitting up here at the table, I hope. But it's about how relentless and how stubborn can we be, and then it is going to be awesome, and we will give Brett his happy ending to the story that he really needs.
Thank you. And with that, I'm going to turn it back to Brad to introduce our next speaker. So please give the panelists a great round of applause. Thank you. Thank you.